Hello and welcome to another logic video. In this video, I'm going to be introducing how to do a proof. And this is going to include a description of or an explanation of how a proof is laid out and what we're doing and what does it mean to go through it. But we're also going to solve this proof. I'm pulling this problem from exercise 18.2. This is problem number 14 from Paul Herrick's Introduction to Philosophy. And one feature about this, so if you're this is equally usable for any other logic textbook, but I should mention that the way Herrick has his exercises laid out is that this exercise only uses 4 rules. This is the first set of exercises for doing proofs. So the only rules that will be needed are Modus Ponens, Modus Tollens, Disjunctive Syllogism, and Hypothetical Syllogism, which I have referenced here on the right side of the screen. Now, when we're doing a proof, we are being given an argument. And we've seen arguments written out in a formal way before in this class, like with categorical syllogisms. Unlike categorical syllogisms, we can have any number of premises. So this one has 7 premises. And just like in categorical syllogisms, we are given a conclusion. Now, one thing to note here, an important part about the layout, when we are given a problem for the sake of doing a proof, you'll always notice on the last line here that we are given a statement and then there is the slash and then another statement. This slash represents the conclusion line, and then this letter, whatever comes after that, it's often a full statement. It's often a more complex statement, but in this case, it's just a L. This is the conclusion. And what we're being asked to do is to prove that this conclusion is valid, can be validly drawn from these premises. And the way we do this is by showing step by step how we can get from the premises to the conclusion. Now, essentially what's going on here is that we have these 4 forms, which are themselves miniature arguments. And the idea here is that we are, these arguments we are accepting as valid. We are taking that, we are assuming that they are obviously valid, and that in fact we can use truth tables and a few other methods to prove that they are valid. But they're easily shown to be valid. They are simple forms, and so we can apply these simple forms to these much more complicated arguments, such as the one we have here on the left, and then like show how these 7 different complex and irregular premises can step by step lead us to this conclusion. So it's essentially taking a complex argument and breaking it down into lots of different simple arguments. And if we can do that, we can get to our conclusion. So the way we do that is essentially, and I'm not going to start this yet. I'm not going to start proving it yet, but what we're essentially going to be doing is writing a new line. So we're going to write line 8. And so it's whatever comes next in the sequence. And we're going to ask, what can we directly conclude from 2 of these previous premises? What can a valid conclusion be? And once we have proven that valid conclusion, we understand that as true. And it can be used as a premise. So it's essentially like we've come to a conclusion, now we can use it as a premise to make a further step. And we just keep building until eventually, and who knows how long that's going to be, but eventually we will aim to get to a line, it's not going to be 11, we will get to a line that is just L. And so once we get to a line that is identical to our conclusion line, our proof has been successful. Okay, so I have not worked out this proof. Maybe I've done it long ago, but I do not remember the solution. And I'm going to be just working through and kind of talking about the process, because this is a big problem solving, like almost solving a puzzle, where we have to recognize patterns, we have to see how different pieces fit together. It takes sometimes a lot of trial and error. The only way to get really good at this is through practice and thinking about it, looking at other examples, but your mind has to get used to thinking of this way. Okay, so let's read through one of the first things I usually do is read through the argument, just start to see a few key patterns. So premise 1 says, if J is true, then I is true. Premise 2 says, if I is true, then R is not true. So already this is kind of interesting because we see if J is true, then I is true, and if I is true, then not R is true. So if J were to be true, we know that not R would be true because these I's kind of connect. Not kind of, they precisely connect. It's kind of like a chain reaction of conditionals here. And we already see how hypothetical syllogism might be a good first step because this fits this pattern. Next up, we see that J is true. Oh, that's useful. So we know we'll be able to prove I, which means we know we'll be able to prove not R. 4 doesn't seem to have any connection with what we've seen before. So this is almost like its own little chunk here that we'll probably use later. 4 says if A is true, then B is not true, and A is true. Well, that's useful. We can kind of see modus ponens built into here, which would give us a not B. So here we can kind of see how not R would come out of all this. Here we can kind of see how not B would come out of all this. Moving on, R is true or B is true or S is true. So this is saying either the left side is true or the right side is true. We see this not B here, but which kind of reminds us of disjunctive syllogism. But we can't use disjunctive syllogism on this because it has to be by itself, and it's currently connected with the R. That's an important thing, that when we're using these forms, you can't just take it from part of the line. You have to take it from the whole line. I'll break this down further as we move forward. But then also we have this not R, and that seems to connect with this. And finally, we see if S is true, then L is true. So if we can prove that S is true, that is going to give us L. And by the way, we notice that L, if L is our target here, we do want to think about where in the argument we find the conclusion or parts of the conclusion. And the only place we find it is line 7. So that suggests, it doesn't prove, but it suggests that line 7 is going to be used near the end of this proof. Okay. Now, let's get started here. Now, I'm just going to kind of, when we're doing these proofs, I will say that this is a pretty easy proof. By the time we get to the end of this, there will be proofs that are much more difficult to solve. And I know many of us are looking at this for the first time and being like, this is the easy one. Are you kidding me? But just hopefully you've learned. Hopefully we're caught up on our lessons and pulling these things together from the past few weeks, and this will start making some sense soon. So on line 1 here, we see if J, then I, if I, then not R. And it helps to have these forms memorized. Really, I don't know how you can go through this without knowing these forms really, really well. And yes, you'll always be able to have a reference for our quizzes because we're all working from home right now, learning from home right now. But it certainly helps to know these rules very well so that we can recognize patterns and move through this pretty quickly. So if J is true, then I is true. And if I is true, then R is true. So we take these patterns, and I'm just going to write it off to the side right here. If J, then I. If I, then not R. So this form we see is identical to this pattern right here, where P equals J. Q equals I, and R equals not R. And that would give us the same P therefore I, P, therefore Q, Q, therefore R. So we notice what we're looking for here is that these, where the Q is, we have an identical statement here, I and I. The Q, or I'm sorry, the R, this lowercase r represents the not R. And wherever that ends up in our conclusion, that whole chunk, everything in that box, everything that's being represented by the R must come down as well. Okay. So if the solution to hypothetical syllogism is if P then R, then we see that J looks like this. This next line of this hypothetical syllogism looks like this. And this becomes our next line, if J, then not R. This is from lines 1, 2, hypothetical syllogism. So that's how that works. And now we can use this as a new premise to further progress in the proof. And as we've shown, as we saw before, as I kind of did a walkthrough of this, or made some guesses here, we can now use this J and plug it in here. If J is true, then R is not true. Therefore, R is not true. If J is true, then not R. J is true, thanks to line 3, therefore not R. So we can just write not R there. And that's from 8 and 3 Modus Ponens. So this, what I'm doing over here is I'm saying which lines I'm using, which lines of hypothetical syllogism match this original form. So line 1 is the first line here. Line 2 is the second line here. And then this is the conclusion from there. Now I said 8, 3. This is this line here. If J, then not R. J, therefore not R. So again, this is the conclusion. This is the first line of Modus Ponens. This is the second line of Modus Ponens. I should say that, you know, this is the first line and this is the second line as we're moving to this step. And now is a good time to mention that the order of these premises don't really matter. They don't have any logical significance. This proof was laid out so we can move. It's easy to sort of work through this problem by starting at the top and moving to the bottom. But that's not always going to be the case. Sometimes you'll be jumping around on these premises. Sometimes you'll be starting at the end and connecting it with something at the beginning. Sometimes you'll reuse premises. There's nothing that prevents you from reusing a premise multiple times. And sometimes you won't use, sometimes the premise will go unused. You just skip over it entirely. In fact, a lot of the problems at the beginning of this exercise set include unused premises, I think, just to help you understand the importance of identifying, or just like exercising, what does it mean to identify the premises that you do need. Moving on, 10. So we've kind of gotten to a dead end with not R. That is symbolized by, you know, guessing before that this was a chunk that leads us to not R. Now we can start, we'll start kind of again from line 4. Here, if A is true, then not B is true. A is true, therefore not B. So we can put not B right there. And that is from line 4, 5, Modus Ponens. So again, if P, then Q has the same form as if A, then not B. A is P, P, P. Therefore, Q is not B. So we just pull down the whole Q and put it right here. That's from lines 4, 4 being identical, being represented by this, 5 being represented by this, giving us our not B. Now, again, we can't use not B here. So disjunctive syllogism looks like we're on the cusp of disjunctive syllogism. It says B or S, not B, It feels like we should be able to do this. However, I should note that when we use premises or when we use statements, we have to know that that statement is true in order to make any kind of conclusion about it, right? And from line 6 alone, we don't know that this is true. We only know that either R is true or this is true. But until we can confirm that the right side is true on its own, we can't use disjunctive syllogism on it, not yet. So line 10 is kind of something where we have to say, we think we're going to use this, but not yet. Instead, we're going to look at this R and the not R. So here is the disjunctive syllogism that we do want to look at. P or Q, where Q represents B or S. And we take the line 9, not R, which is not P, to give us Q. And that's what this is, disjunctive syllogism. So we're going to say 6 and 9, B or S. We're going to write B or S, 6, 9, disjunctive syllogism. Okay. Now we have what we were looking for, B or S and not B. So I'll mention this now too. We can use the same rule again and again. And it's like every time we make a step, we are applying the rules fresh. In other words, what I'm trying to say is, whenever we use a rule, we have to make sure that our symbols here are consistent, right? So if I decide that the first line of disjunctive syllogism, P equals R, then so long as I'm using that form, P has to remain R. And not P must be not R. Okay. I do the step, but now I can start over again. And so in other words, my P can now represent something different. Each step, my P's, Q's, and R's can mean something different, but while I'm engaged in that one step, the P, Q, and R must remain consistent. So here, B or S, not B. Now my P equals B, and my Q equals S. So not B is like not P. That's from this here. And I can pull down S, which is our Q. So I'll write S from B or S, line 11, and not B, which is line 10. And that is disjunctive syllogism. Finally, we have line 7, which says, if S is true, then L is true. S is true, therefore L is true. That is from 7 and 12, Modus Ponens. Okay. And now that we have our conclusion, we have proven our conclusion step by step, we can trace our proof, and we have therefore proven that L is a valid conclusion. And that's how to do a proof. Just a couple notes, like I sometimes get the question, why do we have to lay it out like this? So this is part of a tradition that is, we see it in math and we see it in the sciences as well, where we want to make sure that when we prove something, it's not just provable for us, it's provable for anyone who wants to look at our work. And the point of this isn't just for the sake of your teacher being able to check your work. The point of this is, you know, in the real world, I mean, this is the real world, but when we want to make an argument and we want people to believe us, we want a critical thinker, a skeptical thinker, to follow along with our argument and to accept it. We want our ideas to spread. If we think that we know the truth, we want to be able to show that this isn't just a hunch. This is something that is worth accepting. And for that, we often have to go against what people believe. So in the sciences, we have a whole system for this. It's called the scientific method. The scientific method includes, of course, things like making a hypothesis and testing that hypothesis and so on with using an experiment. In many of these elements are useful just for science through experimentation. This isn't an experiment, certainly not in the way that science does experiments. But in science, we also want to make sure that our experiments are repeatable, is what we say. Which means that for example, in the current pandemic crisis, there have been scientists working in laboratories around the world trying to figure out what would work as a vaccine. And to do that, all these different scientists are trying to understand what the coronavirus is, understanding how the human antibodies react to it, respond to it, and not just how one particular human being's antibodies respond to it, but how antibodies across the entire human race respond to it. And in order to progress, they want to share information. They want to break down this big problem of how to create a vaccine into lots of smaller problems. And this is where it pays to be a specialist, where it pays to have done years or decades of work in infectious diseases to understand where there are patterns, where there are similarities, and where there are differences. What might when we see a particular combination of, say, an antibody and the virus, and how all the different ways that they have observed it interacting, like that requires specialized kind of knowledge that I certainly don't have, that you would need to have studied a lot on. And when the scientists in these laboratories come up with a solution, it's one thing for the scientists to say, hey, I discovered the solution. It's another thing for other people to be able to look at that solution and believe that it is trustworthy, because this is a factor, not just in the sciences, but in every aspect of the search for truth. Whether that's on scientific matters or whether that's on religious matters or political matters, if we care about truth and not just individual hunches, which is sometimes important too, but in matters of science, and for a lot of people on matters of politics or ethics, having some kind of objective truth is important. It's critical. And for that, we want to be able to see and understand how another person with a different mind, with a different set of assumptions, with a different thing that they're looking at, gets through their process and comes to the vaccine, comes to the conclusion. And for that, we want something repeatable. This, by laying out our steps one by one and showing every rule that we used and every step, every premise that we used with that rule, we are essentially doing the logical form of a scientific, repeatable experiment, except for logic and philosophy. Where here, anyone can look at this argument. Anyone might see this argument being like, how on earth do I solve that? How do you get to the conclusion? And somebody might come and say, I solved it. Well, prove it. Okay, I'll prove it. Because it doesn't matter. If you say you prove it, that's not proof that you've proven it. That doesn't mean anything. If you say you found evidence, if you say you found a truth, it might persuade you. It might persuade some people who trust you, some people who know you, or the very gullible. But it's not going to persuade it's not going to persuade a skeptical, critical thinker, which is what we are encouraging all of us to be. Like, that's where we want to get to. And by doing this, we are guiding essentially our audience on on where we started, where we all agreed the premises are, to the path of the conclusion. And this is essentially a practice in how to do that. Now, what does that mean for you? Like, I know most of you are probably never going to touch this again after the semester's over. But again, and I've said this before, it's not about the specifics of doing proofs within propositional logic. It's about thinking, it's about using this as a tool for thinking about what does it mean to think, and what does it mean to engage in ideas? What does it mean to work through an idea? What does it mean to argue for an idea? What does it mean to present that idea to another person? Think about this when you're writing an essay for one of your other classes. What does it mean to write an essay? It means to write an argument. And when you're trying to prove something in your argument, it often requires an exploration of ideas. It often requires using, it's going to depend on which discipline you're working in. Is this an essay for an English class, or an essay for an art history class, or an essay for a social sciences class, an essay for a philosophy class? All of these classes, all of these different disciplines will have their own version of their rules. They will have all their own versions of what counts as evidence, what counts as something you can refer to. But they all want you to build an argument, and they want you to be able to express that argument to a different person other than yourself. How do you get all the elements of that proof onto paper so that a skeptical, critical reader can read through this? In the larger sphere, just thinking about the state of the world right now. If you're watching this video, you might later in the world, you might it might help to be reminded of the fact that now, November 19th, 2020, is just under 3 weeks, just over 2 weeks from the election we had here between Donald Trump and Joe Biden. And we are currently in a state where Biden has been declared the winner by all the major media sites, by the vote counts. It looks like he's won enough to be declared the winner. But there are questions that people are raising about the validity of the votes, about the elections. They're making arguments. And arguments are flying everywhere. And these arguments matter. Arguments matter. They matter in politics. And right now we're feeling this in a very real way. Are people making good arguments? Are they showing their case well? Are they going far enough? Are we being ripped apart because people do not know how to build good arguments, because people don't know how to critique an argument? I believe that this is to get very I don't know, sentimental, not quite the right word, grandiose maybe, but learning how to think through an argument is critical for our democracy. And I think that this is a very good way to help us think about what constitutes a good argument. Like, this is the foundation of it. This is an argument in its simplest forms, not its most complicated. But if we can't do it here, where can we do it? This is a good practice ground for thinking about what makes a good argument, as with everything that we do in school here, I hope. Anyway, that's my introduction to how to do a proof, with some reflection at the end there. Hope you have a good day, and I will see you next time.